Go. New notes, new chapter, new things. Quadratic equations. So we are into a unit on quadratics. So this unit is going to include graphs that are parabolas that open up like a cup or down like a frown. All of our graphs should look like this. We should not be getting straight lines. We should not be getting anything except U-shaped graphs. So that's one way to tell if you did something wrong. If your graph doesn't look like the letter U, you did something wrong in this chapter because they should all be a letter U. The standard form for these graphs is y equals ax squared plus bx plus c, where a, b, and c are just numbers. What number? Doesn't matter, any number. So an example of what this could look like if I put numbers in, you could have an equation that reads y equals 3x squared minus 5x plus 4. That could be an example of a quadratic equation where the a, b, and c are represented with numbers. Oh, I didn't give you a packet? Thank you. Claire, you're so thoughtful. And poor Patricia was just trying to write everything down. Okay. So there are some things that we like to find when we are doing these problems. There are some important pieces of information, some little details you could call them. One of them that's important is the vertex. So the vertex, by the way, let's say your graph opened up. The vertex is the lowest point or the highest point on the graph, depending on how your graph opens. I also kind of think of the vertex as where your graph originates from. So it kind of starts there and it opens up, or it starts and it opens down. So that point is your vertex. And there's actually a way to calculate it. So the vertex is an ordered pair. So it's an x comma y. And leave me a bunch of space. But your vertex is always going to be an ordered pair. It's a point. How do we calculate it? So this is the formula. So there's actually a formula for this. We get negative b over 2a. So remember the a's, b's, and c's up here? If we plug in the a and the b here, we can find our vertex. And then once we do that, we can go back through and find our y value. And I'm going to show you how to do this whole process in a minute. So right now I'm just giving you the formulas and the basic information, but we're actually going to do it together in a moment. Next, the axis of symmetry. So the axis of symmetry is the line that cuts the graph in half. Do you see how I drew those two lines in? Do you agree they cut my graphs in half?
Yes.
Okay. So the axis of symmetry is always going to be a vertical line. Do you see how it goes up and down for both? So because it's a vertical line, it's always going to be in the form x equals. So it has to be this way because it is always a vertical line. Alright, so the kind of cool thing is that this formula right here to help you find the x coordinate of the vertex, it's the same formula we use to find the axis of symmetry. So when you calculate this negative b over 2a number, it's actually kind of a BOGO. Like you calculate it, but you got two things at once. You got the x coordinate of the vertex, but then you also got the axis of symmetry. Alright, also, these graphs have either a maximum or a minimum, and it depends on the way the graph opens. So I'm going to draw another parabola. You have a maximum if your graph opens down like a frown. And your maximum has another name. What did I call it a minute ago? The vertex. So your max or min is also your vertex. So you could call it either, they're the same thing. Remember that our equation is ax squared plus bx plus c. That's our general equation. If your graph opens down and you have a maximum, your a value is negative in this situation. So a negative a value is when your graph opens down like a frown. So I'm going to come over here and basically write the opposite of everything I just wrote. So here's my vertex, and this time we're also going to say, hey, it's a minimum. Again, if I have ax squared plus bx plus c, and my graph opens up like a cup, what type of a value do I have?
Positive.
Yeah. A value is positive. And to tell you how long down like a frown and up like a cup is stuck in my head, it's been since like 1999, because that was when I heard my pre-calculus teacher say it, and I've said it that way ever since. So some things just get stuck in your head, right? Like that jingle on the TV or whatever it is. Up like a cup, down like a frown. All right. So what are our steps? We kind of just talked through it up here. I'm going to basically repeat myself. So bear with me. The x-coordinate of the vertex, I'm going to get out my highlighters. The x-coordinate of the vertex uses the formula negative b over 2a. So again, I'm kind of writing down some of the same stuff that I did a minute ago. The next thing we want to do when we are graphing, so that's step 1, is to find the vertex. Step 2 is going to be able to find a table with 3 points. And you always want the vertex to be in the middle. And then you're going to go ahead and plot the points that you see. And then we are going to graph and state our domain and range. Do you remember that we had a couple different ways to do domain and range? Like we had the set builder and the interval notation. For this unit, we're going to stick with the same notation the whole way through, so you don't have to worry about switching. We're going to stick with interval notation for a couple reasons. Number 1, because it's nice to have consistency and stick with one thing. Number 2, because you use interval notation more often in upper level math, pre-cal, calculus, and beyond. So that's why I would prefer to stick with interval, because you're going to see this more down the road. And so I'd rather have us focus a little more on that. So those are our steps to help us graph. All right, let's graph and actually do these things that we've been talking about. We only have 2 examples today because they take a minute once you do all the things. So we're going to do these 2 problems. And then tonight's homework is a worksheet for the most part. I'm going to have you do a couple more out of the book, but it's mostly a worksheet because I want you to be able to kind of have it all set up for you, if that makes sense. So this is your homework worksheet tonight. It looks like this. Kind of walks you through it. Okay? All right, here we go. Let's think back through those steps. Step 1 said to find the vertex. All right, before I find the vertex, I want to think about my A, B, and C, because I need those to find the vertex. My A value is what's in front of x squared, so 3. My B value is what's in front of x.
-6.
And then my C value is the number that's kind of sitting by itself, 1. Okay, so those are my A, my B, and my C. Step 1 wanted me to find the vertex. So remember that it's negative b over 2a, comma, the y value. And we're going to have to calculate the y value on our own. All right, so for this problem, negative b. So negative 6 is really 6 divided by 2 times a. So 2 times 3. So all I did is I took these things and I plugged them in. Well, what do we know 2 times 3 is? 6. 6 divided by 6 is 1. So the x-coordinate of my vertex is 1, comma, Now we've got to find the y value that goes with it. So I'm going to plug the 1 in. Whenever you plug in, you want to plug in a parenthesis house. Because if you don't, you're going to get the wrong answer. I'll show you why. Let's pretend for a minute that our vertex had been at -4. I know it wasn't, but let's just pretend together. If I square -4, it spits out -16. Is that really what I want, though? No. I want this. Because I want -4 times -4, I want +16. So you have to put it in a parenthesis house. Otherwise, your calculator is going to say, oh, let me square that 4 and then reattach the negative. That's what it's doing. That's how it interprets that. So make sure when you plug in a parenthesis house. So 3, parenthesis, 1, close it, square it, -6, parenthesis 1, plus 1. Yes, I'm using my graphing calculator, but you can type this in the exact same way on a scientific. So it doesn't have to be a graphing calculator. Your scientific can also handle this completely. And then hit enter. What do you get? -2. Now, the vertex is my middle point. It's where things originate from. So I'm going to write it in the middle. Remember when we did the V-shaped graphs? We did the absolute value graphs. Remember those? And we found a point on either side. That's what we're going to do here too. All right, so if I go on this side of 1, if I go smaller, what's smaller than 1? 0. And then if I go on the other side, I'm going to put in what? 2. Now, here's the other trick, is you only have to plug in 1, because this graph has symmetry. So I'm going to plug in the 0 into this equation, like what I just did with the 1, but I'm not going to have to plug in this one, because this is going to give me 2 answers for the price of 1. So if I plug in 0, this one I can do in my head. 0 squared is 0 times 3. 0. Well, I see what you were trying to tell me. -6 times 0. 0, right? So we've got all sorts of zeros. 0 plus 1 is 1. Because our graph is symmetric, if I went 1 unit to the left and it's at +1, if I go 1 unit to the right, it should also be at +1. So you only need to calculate one or the other. It doesn't matter which one. These answers are going to match though. So you could plug in 0 or you could plug in 2. I plugged in 0 because I thought it was easier, but these answers will always be the same. So these two are always the same. And again, this point that was in the middle was my vertex. So the only reason those two will be the same is because my vertex was in the center of them. All right, step 3 is to actually graph. Here we go. Over 1, down -2. On the left, we had a point at 0, 1. On the right, we have a point at 2, 1. And this is a nice smooth curve. So when you draw it in, this is not a V-shaped graph. Those are something else. Those are the absolute value ones. So try to give me a curve. Some of them are easier to give curvature to than others. Here is my nice U-shaped graph, not a V. They should all give you letter U's. Again, if you're not getting a U, you're doing something wrong. All right, down here for step 4, we need domain and range. Domain, remember, is X. We're thinking left to right. Range is Y. We are thinking up and down like a mountain range. Okay, so domain. My graph is expanding out left and right. Is it going to touch all things to the left and all things to the right? Yes. And that should always be true. When we have all real numbers in interval notation, remember this was our way to communicate that. We said -infinity to +infinity. And we use those parentheses to tell people you can't really get to that point. You can't really reach out and touch that point, that that's where you're headed. Okay, the range is different. The range is going to have a restriction. Do you see how I don't have any graph down here? No graph, no graph, no graph, no graph. When do I finally hit graph? -2. So -2, and then where does it stop? Or does it stop? It doesn't. It goes to infinity. And so we represent that again with a parenthesis. Now, remember, you can write positive infinity for both of these, but do you have to? No. You do need to put the negative with negative infinity. Also, because I can include this point, that's why there is a bracket there. And also remember, when you're doing this interval notation, it goes low to high. Left to right, low to high. Okay, let's do one more of these. Are you ready? Yes, Miss Vessel, we're so excited. Oh, good news. Okay. A value. When you don't answer me, it gets all weird and I have to respond for you. A value is what? -1. B value is?
4.
C value is?
-2.
Oh, good. See, I scared you guys. You were like, we don't want to hear her talk in her weird, creepy voice again, so we're going to actually say stuff. Good news. All right, let's find our values. So we need -b/2a, comma, and then we're going to find our y value that goes with it. So -b would be
1.
negative, no,
Wait, -4.
-4 divided by 2 times a. So basically, I'm just substituting in. Remember, we talked a lot about substitution last chapter when we did those systems. So I'm just subbing in. So here's my -b. Here's my 2 times a. So the 2 is just always there. The 2 isn't a letter. Like there's always going to be a 2. Whether you like it or not, the 2 is going to be there. All right, so in the top, I have -4. What is 2 times -1? -2. What is -4 divided by -2? 2. All right, so now I have the x coordinate, but I need to go back and find the y coordinate. This one, when you plug in, because the negative's out front, it'll stay out front. So I'm going to plug everything in. I put it in parentheses houses, but because this negative was outside, it stays outside. So on my calculator, I'm going to type it in exactly as I see it, very literal. Negative, then a parenthesis, then a 2. Close it, square it. +4, parenthesis with a 2, -2. What'd you get?
2.
Drum roll. I also got 2. All right, so that is my vertex. So again, I put that right in the middle. In terms of x, what other points should I find? So if I know 2, 2, what other x value should I find? 1 and 3. That's right, we want either side. And again, the shortcut is plug in your favorite. You don't have to plug in both. Now, here's the nice little trick if you have one of these calculators, and I think you can actually do it too on the scientific. If you go up, do you see how it lets me? Oh, it's not going to let me do it. I guess I have to copy and paste it. If you arrow up on the scientific, you should be able to arrow into the last equation you plugged in and just type over it. Yeah. So I'm just going to arrow up into this equation, and I'm going to type over the 2's with 1's. Now this 2 was a part of the equation, so that one stays. But do you see where I plugged in the x's in the parenthesis house?
Yes.
Those are going to change to 1's. So again, just trying to give you a shortcut. If you don't like the shortcut, you can just plug it in like normal. Again, remember that these two numbers will always be the same. All right, let's graph. I have a point at 2, 2. So there it is. There's my vertex. This graph should open down like a frown because of my -a value. I have a point at 1, 1. I I have a point at 3, 1. Again, if it's not a U-shaped graph, you did something wrong. Give it some curvature. Domain. Bless you. And I'm going to add one kind of little piece of information before we move on to homework, because this is all we have for today. So let's talk domain, and then we'll talk range, and then I want to add one more little tidbit to this graph. Domain, is it going to go down and out and hit everything left to right?
Yes.
Yes. Your domain will always be all real numbers. There's never a situation that you're going to encounter where it's going to be different. It's always, always all real numbers. Okay. Now, this graph goes down to negative infinity, but where does it max out? It maxes out at 2. So remember, low to high. Negative infinity up to positive 2. Parenthesis or bracket? Bracket, because we can actually get to 2. Like 2 is a place we can head to and get to. Now, on the homework, there's 2 other little pieces that it's going to ask you about, and it's not bad. If it asks you for the maximum, it's the same as the vertex, yes? So it could ask you for a max or a min. You need to know that it's the same as the vertex. We already found that. It's right here. The other thing it can ask you is for the axis of symmetry, which we talked about briefly. I call it AOS for short. The axis of symmetry is, remember, the line that cuts it in half. It's always x equals, and it's always the x coordinate of the vertex. So for this one, it would be 2 because of this 2. So this value, still got a highlighter out somewhere, this number and this number will always be the same. So the x coordinate here and this value for the axis of symmetry will always be the same. So again, the only bonus things they may ask you on the homework from what we were just doing in those last 2 problems is tell me the min or max, but again, that's the same as the vertex, and tell me the axis of symmetry, which is fine. It's the same as the x coordinate of the vertex. So a lot has to do with the vertex. It's a super important point on our graph. Good? Okay, so I'm going to give you a worksheet in just a minute. So your homework for assignment number 1, remember we start back at scratch. Your homework for assignment number 1 is a worksheet. There are 3 problems on the worksheet. And then I'm going to have you add a couple more. I'm going to have you add from page 149, numbers 1 through 3. So we're going to do the worksheet 1 to 3 and the book work 1 to 3. Okay. Do you see on the back of this that there are extra problems? We're not there yet, so we're not going to do these. Do you see them? Okay, we're going to save those for Wednesday. That's for us on Wednesday, are these problems. So on the worksheet, you're going to do number 1, number 2, and number 3. The ones that have like big tables of stuff. Then you're going to open your book and do numbers 1 through 3. So you have 6 problems total. What questions do you have before we start working? I will put my book on the dock here, and I will be around with the worksheet.